So we want to be able to create a templated vector. Guys, going slow. Come on. So as soon as this field finishes, we want to be able to create like a vector similar to the one that's provided by the standard library, just to give you guys an idea of how that's implemented. And again, we want to be able to have vectors of any different types, like vectors of ints, vectors of strings, vectors of doubles. So if we want to have to do the same thing, but we want our elements to be able to have different types, what are we going to use? Right, so I don't have to write a string vector class and an int vector class and a double vector class. What am I going to use so that I only have to write this code once? That's type independent. Yeah, templating. So remember, when you're doing your templating code, all the code goes into the header, right? The header file. So vector over here. And so how am I going to declare my class vector as being templated? Well, template, right? Type name. And then we name the name of our type, right? I'm templating over some type T. T is the stand-in for the type that I'm going to be creating a template of. Or creating like, T is the stand-in for the type that I'll be using later on, right? T might be a character, T might be a string, T might be an integer later on, but T is that stand-in. So, why is this not? Oh, I guess it didn't get actually added. So, what members are going to be inside of my vector? What do I need to represent it? An array, right? And I need a length, right? So int len. And then, do we want to use a unique pointer or do we want to use, well, we won't use unique pointer here. We'll just use regular pointer. So how can I say I have a pointer to whatever my type is? T star, right? Contents. Right? T is the stand-in. Public methods are for how I create things. So what might I want to do first? We might have constructors, right? So we might have a constructor that takes no arguments. Right? That would be like an empty list, right? We might want a vector that takes in what? Right? We're going to be like a little bit lazy and we'll just define one, pound include, not that one. Vector. And we'll also just have another one that takes in a vector of std : vector. std vector. And this one might be a const std : vector reference. Wait, why is it complaining? There's a vector whose name is vector in std. Oh, a vector of type T, right? Because vector itself doesn't name a type, right? Just vector, this is not a type, right? It has to be a vector of some instance, right? And we want to be able to accept a vector of type T, right? The same type as we are, right? The constructors that you have here are just for how you want your thing to be created, right? And if you wanted to be able to be created in different ways, provide constructors for that, right? And so you probably will need one or two constructors for your like link or your nodes. We might have one for a copy constructor, which would be a vector const const my type of vector reference bridge. So we'll now go and implement these. And so one thing that sometimes it forgets to do is put the T there, but it did this time because my class name here is a vector of type T, whose constructor is called vector. So over here, what should contents be initialized to in the empty constructor? Null pointer, and my length should be 0. when I take in my original vector, oops, don't want that. When I create my original vector, what should I do? Well, contents should be equal to a new, right? A new what? I want a new t of size std vector dot size. Right? Here I'm creating new space for size number of elements, right, of type t. So I created an array of type t. And then down here, for my next parameter, what should my length be equal to? Std vector of dot size, right? So I've created space. Now what should I do? For loop, right? So for I equals 0, I less than my length, right? Plus plus I, std, or oops, contents at I is equal to std vector at I. Everything making sense so far? Any questions? Yeah. Yeah, that's all constructors do. They tell you how to build an instance of the class, right? And so if I'm building one from an std vector, I need to make space to fit all the elements. My length should be equal to the number of elements that are in the other guy. And then I need to copy over all the values. Anything else? Yeah. This guy over here? Yeah, he's just like a normal vector built in from the standard class vector. And then we might also need to be able to copy ourselves. So how do we copy ourselves? Yeah, we're in the copy constructor, so how do I copy myself? Right, the copy constructor tells you how to create a copy, right, from the original. So how do I create my copy? Yeah, we copy each element over and we make sure that we're the same length, but we also need to make the space. So contents equals new, oops, contents, here, say new t of size orig.len, and my len should be equal to orig.len. And then I need to go through and more or less do this exact same thing. But now this guy's called orig, and he's going to be using bracket I. We also need to define our destructor. So virtual tilde vector. And so what would we need to do inside our destructor? Yeah, we got to release the space. So if contents delete bracket contents. Great. So destructor done, right? Delete the space we've dynamically allocated. We could say length equals 0. It won't hurt. It won't, doing this probably isn't going to be mattering because this thing is destroyed and so it's gone. But contents equals null pointer. So what methods would you want to provide on your iterator? Yeah. Oh, why did I have brackets here? Because when I dynamically allocated space, I used the bracket form to create space. If I had only created a single element, I would just say delete contents. But because I created multiple, I need to use the bracket here. Yeah. Yes, I had to check if it's a null pointer beforehand, which I did here on line 47. So dot at on a vector accesses the element at position I. It's equivalent to doing the square brackets I, but it actually does bounds checking. And we'll throw an exception if we go out of bounds. Any questions here? Okay. Now let's say I wanted to provide some methods like front and back, where front returns a reference to the thing in the front and back returns a reference to the thing in the back. Right? So what should my return type be? Right? So I want this to return a reference to the thing that's at the front of my list. So what should my return type be? T reference. Right? Because I wanted a reference. And then again, a lot of times when you're doing things like front, you would also need a const T reference front const to give you both a const and non-const reference to the front. And then we'd also have a T reference back and a const T reference back. Okay, great. What should this function do? I want to return the thing that's at the front of my list, the front of my vector. Return contents at 0. Right? Return the first thing. And then again, unfortunately, const and non-const, right? Out of the same thing. And for back, we should return contents at length -1, right? Because zero-based indexing. And then once again, we'll do back down here. Any questions? Yes. So I can have a non-const version so that I can actually modify the elements. So I can say like my vector.front equals 7, and it's going to change the first thing's value to be 7, right? But with a constant, I can only read it. Any other questions? Yes. So the compiler will figure it out based on the context, like whether the reference you have to the thing is const or not. I think in general it's going to prefer to call the const version unless non-const is needed. Any questions? So what other things would you want to do with your vector? You might want to like insert or push back or push front, but we have limited time today. So probably the thing that you're most interested in is iterators, right? Right? And we might also want to provide a getter, right? We might want to provide an at. So we'll put that one in there first before we move on. So we might have a T reference at int I and a const T reference at int I. So here we could just return contents bracket I. So one thing you guys like should probably, maybe, hopefully be worrying about is const here is that what happens if somebody keeps giving me bad values and they get seg faults? You just worry about that or not? So for right now, we're like not caring, right? But in general, once we talk about exceptions, you would throw an exception if they went out of bounds trying to access your member. So here, I would ask for a new C++ class, and I might call this guy like forward iter, create the header only. So does this iterator need to be templated? Yeah, because we need to have passed that template parameter over to whatever we're iterating over, right? So template type name T, and what members do you have to have here? You have to have where you're at right now, right? So we need an int position, and what else? Why is this? Well, we're assuming that we're going to the next thing always, right? We need a reference to our vector, right, to be able to go over the elements. So over here, we're going to need to include vector. And since this guy is just a forward iterator and he's not constant, we are going to have just a regular reference, right? If we were a constant forward iterator, we would have a const reference to it because we don't want to change it, right? And that's really going to be the difference between our forward iterator and our constant forward iterator, is whether we have a reference to it or not. So I need a vector of type. What type of vector? T. Reference called, like, you know, a vec, whatever you want to call it. And then this is going to end up being some circular inclusion. So we need to do some forward declarations. So template type name T, and I have class vector. I'm forward declaring my class vector over here. And then, oops, I'm also going to have to forward declare over here later on forward iterator.h for my forward iterator. Great. So public, I need a constructor, right? What should I probably be taking? A vector, right? So here I'm going to have forward iterator, and I want a vector of what type? T, right? Reference, the vec, and I might also provide a position. And I might also have another forward iterator that just takes in a vector of type T, reference the vec. I'm also going to be very explicit and say my forward iterator of no arguments equals delete. I don't want one that takes 0 arguments. You can't create an iterator who's an iterator over nothing, right? Yeah. Sure, we can create a copy constructor for the forward iterator. So I have a forward iterator. What would my arguments be? I'd have a const forward iterator of type T, right? One of the biggest things to forget in all of these places is when you're writing this, is that you need to keep templating. If the type is templated, right, you need to say of what type, right? And so here I explicitly want a forward iterator of some type T. Has to be the same type as me. Okay, great, this guy first. So what should I do in this constructor? What should I make my the vec equal to? Well, probably the vec. And my position should be equal to position. Woo! Right? So like a lot of this code you're going to be writing for doing this homework is going to be kind of dumb code. It's not going to be too complicated. So here I'm going to forward this construction to my other forward iterator. But he's a forward iterator of type T. And he wants to take in the vec. And let's assume that if we don't give an argument, we want to start at the beginning. So 0. And for our copy constructor, how would we want to copy things over? What would I do? I probably want to copy my position over and copy the vector over. These guys, I need to be flipped around. I just need to copy over the contents, right? Which is that any different than what the default constructor does? No, so if I'm really lazy, instead of actually writing this, I can just go back up here and say it's equal to the default. Thank you. Great. I don't have to write it, right? If all I'm doing is just copying over the members individually, just keep copying each member over, the compiler can do that for you. You just say equals default. In vector, right, we couldn't say that because we needed to actually create new space, right? And then copy the elements over. We let the compiler handle the copy constructor. Our lengths would be the same, but we'd be pointing to the same area in memory, right? We'd have one contents vector, and both of our vectors would now be referring to it. So changes, if the copy made a change to the contents, the original would see the change. If the original changes the contents, the copy would see the change. So for an iterator, what else do I need to provide besides some constructors? Yes? Pretty much, if we just the default, all it's going to say, assuming like, we have a ridge, it's going to say this arrow the vec equals a ridge. This arrow position equals a ridge dot position. Correct. The new one won't change. This is correctly creating a copy in this instance, right? I guess that we could say that we won't be able to change the position in the copy, right? Changes to the position in one wouldn't affect the other. And but if we changed a member of the vector, change an element of the vector, both the original and the new one would see that because they're vectors, they're iterators over the same vector, which makes sense. So what other operators would you want to provide here? Probably need a dereference operator, right? And what should my return value for my operator dereference be? What should my return type be? T or T reference if we want people to be able to modify it. And we probably also need a const T reference so if people don't want to modify it. Okay, so here we have operator star. Generate. What are you doing? Come on. Oh, that's why I got confused because I didn't put const here. There we go. Okay, so what should operator star do? We want to return the vec dot at our position. That makes sense? Because the position is keeping track of which element that we're on. And then the const version, well, he's going to do the exact same thing. So we have our dereference operator. We also probably need to be able to go to the next thing, right? So we probably need an operator plus plus, which returns a forward iterator reference of type T. Operator plus plus. Is this the pre-increment or the post-increment? Pre. How would I specify the post-increment version? Well, right, remember I put this little dummy parameter in there. It's not ever going to be used, but that's what it looks like if you want to do post increment. Because that's what it says to do. Don't worry about it. Okay, so how would I advance myself to the next thing? Pause plus plus, right? And then we want to return a reference to ourselves, so return star this. Okay. Right-hand side operator, or like the post increment, right? This guy's, remember we talked about this trick last week in discussion? So I want a forward iterator of type T called copy. We want to be a copy of who? This, right? Then I can do plus plus on star this, right? This moves to the next thing, and then I can return the copy. Right? This is the copy, hasn't advanced anywhere. So he's still at the same location, but this has moved on. But I return back the copy, so you're still referring to the old thing in the expression, but then when you go on the next line and you use, the iterator, it will have advanced the next one. So it's all good. Okay, what other operators would you want to provide? You have to, like, so operator minus minus, we could do that. It's pretty easy. Operator minus minus and const forward iterator of type T. Operator minus minus with this dummy integer. Okay, so what should I do in operator minus minus? Right, probably just minus minus pause or something, right? And then I return self. And then what should I do in operator minus minus post version? Yeah, copy and paste the plus plus, but change the plus plus to be minus minus. Right, and hopefully you're seeing like this is just stupid. What we're doing here, like hopefully you're not being like blown out of the water by the code that's here because it's very basic. And the code that you're gonna have for your iterators is going to be very basic. Not exactly this, a little bit different because you're dealing with pointers. The elements aren't next to each other in memory. They're going to be at different spots. Right? We also need to provide an operator equals equals, an operator not equals, so that we can use it in iteration. So we want bool operator equals equals, and then we accept a const forward iterator of type T, right hand side, const, and then bool operator not equals const forward iterator of type T, right hand side, const. Ooh. And then we're also going to provide these. They aren't necessary, but operator bool const. So the ability to convert ourselves into a bool, and operator or bool operator not const. So we'll start with operator bool first. So this is going to convert us into being valid. So we want operator bool to return true if we're valid and false if we're not valid. So how can I check if I'm valid or not? What's it mean? So like for it to be valid, it means it's dereferenceable. And actually, if I dereference it, I'll get to a correct object or something that's there. My position has to be in bounds, right? So I can just return that my pause, it has to be greater than or equal to 0, and the pause has to be less than or equal or less than the vector size, which we didn't provide a method to get that, so we'll provide one back here because I'm okay with making this public, right? If you didn't want to make this information public, what would you do? Yeah, you'd make forward iterator my friend, but it'd be a forward iterator of type T. Making friends with iterators or making templated friends has issues. I'll let you guys know that in advance. So be careful making friends with templates. But so here we will have an int. Oh wait, we can just have the compiler generate that for me. Code generate getter len. Great, thank you. The vec dot get len. So this is how I'm in bounds. So operator not would return false if we were out of bounds. So here, this is pretty simple. Just return static cast to a bool. Sorry, this, and then negate it. Right? This guy over here is calling the operator bool to turn me into a bool, and I return not whatever this function returns. That's all that's going on there. Questions before I keep trucking? Okay. So operator equal equals. So for two iterators to be equal, what needs to be true? Generally, they have to be like iterating over the same vector, right? And if they're iterating over the same vector, they have to be at the same position, right? We're also going to declare that if two vectors aren't valid, right, but they're iterating over the same object, they will also be considered to be valid as well. Right, so two iterators that are like out of bounds but over the same vector, we're going to consider them to be equal regardless of how they're out of bounds. Make sense? So we might have to say something like if the vec, the address of the vec doesn't equal the address of right-hand side dot the vec, return false. I want a reference. Wow, that's interesting. Whew, okay. So if both the left-hand side and the right-hand side are valid, we should return. The positions have to be the same, right? My position is equal to the right-hand side's dot position. And otherwise, we want to see if they're both out of bounds, so not valid. Does this look familiar at all? Should look really familiar for what we did with the iterators last week. And a lot of times, defining whether they're equal is more or less this. Yes? We're not checking to see if the vectors are equal to each other. We're checking to see if these addresses are the same. Right? Notice I did ampersands here. I checked to see if the address of the vec is equal to the address of right-hand side the vec. This works because we have references to these objects, right? And if you take the address of a reference, you get the address of the object. So it's giving the address of the original thing. Right? And then we need operator not equals. So what should we do for operator not equals? Maybe return not. Right? That makes sense. We'll call this function up here to see if they're equal, and then we'll return not that. And this should be a reference. So great, we've pretty much finished implementing our iterator over this class. That's it. Yeah. So at the beginning, because there is a circular reference, right, between a vector or the forward iterator and the vector, these guys both have a forward declaration of each other. So forward iterator forward declares vector, and vector forward declares forward iterator. You would have to do something like this if in your if your iterator classes include your doubly linked list and your doubly linked list includes your iterator class. Then yes, you will have to do these forward declarations. It's slightly implementation dependent, but yes, there could be a way. Right, and now over here in vector, right, we're going to provide our begin and end methods. So what should my return type for begin be? Forward iterator of type T, right, begin. And we want a forward iterator of type T, end. Right? These guys are the non-const versions. If you had const versions, you'd have ones that would be called begin that return const forward iterators, and you would be const at the end, right? But like the const here I'm referring to is the name of the class, not the keyword const, right? Because you still need to be able to change your constant iterators to move to the next object. So what should begin return? I want to return a forward iterator over who? Me, right? This. And I want him to start at the beginning, 0, but it's where it defaults already. So we're done here. And then for the next one, end. Where do we want the end to start at? Our length, right? 1 beyond the end. So now over here in main.cpp, I could say like, hey, I want to include my vector class, not in triangles. Vector. And I want to include vector.h. And we didn't really like put any ways of like adding things, removing things right now. So the only way to get stuff in there is with a standard vector. So I might have something like a vector called my vec of type going to accept a 1, 2, 3. Well, that would let me to modify the elements that are in there, but I couldn't change their values. I mean, I could change their values, but I couldn't like insert or erase things. So here I want a vector of type int. Great, right? Or I might include string. I might have a vector of type std : string strvec, and it might have as its contents bob and at, and that's fine. And so now let's say I wanted to print those values. We could do something like for, oops, need to include forward iterator here. Oh no, actually don't. So for auto iter equals myvec dot begin. Oh, we can just do it the easy way. For const auto reference val in myvec. Include iostream. Great, we can try building now. Let's wait for the errors. Okay. I forgot a semicolon here. Try again. A semicolon here. Try again. Hey, it built. Let's see if we segfault at all. Hey, we didn't segfault. We printed things out. We went forward. That's it. You guys have 7 minutes. What are your questions? Yes. Oh, we don't have time to put all that stuff in there. But if you want to, you can go and look on our class Google Drive under user-defined types for the string class, and they show you how to do it for the string class. Yes? So we are using the forward iterator here in main when we're using this for loop. By default, these for loops, what they more or less translate into is for auto iter equals like myvec.begin. Iter doesn't equal myvec.end plus plus iter const auto val reference equals star iter. Oops. Oops, I did that. Auto reference. Right? So these for loops up here, this is what they're being translated into internally. Yes? I haven't defined what? The operator column? Operator colon colon? And the for each? Oh, this? Oh, that's syntax. It's not an overloaded operator. This is just syntax. Yes, so these guys over here are being more or less automatically translated to what you see down below. Right? And if we run this, it should still work. You guys may have some long compile times for these projects because the templating takes a while, because you have to expand all the templates and build these classes and do all the substitution. And the Google test stuff also uses a lot of templating too. So like for me, it took like 20 seconds or something, 10 seconds to like compile. We will be talking about Google testing discussion this week. So if you're on Monday's discussion, make sure to watch the videos so that you can catch up on that stuff. It's not too bad. You don't actually have to use it, but you can see how I've used it to test your code. Any other questions? Yes. Oh, so you're talking about here inside the forward iterators, why do I have a reference to the object as opposed to the copy? Over here in main? A const reference? Oh, I probably like in a lot of these functions, I accepted const forward iterator references like here. It's because it's much cheaper to pass the reference than to create the copy. Here, these would just have to copy the reference and copy the position. But again, so it's not too much to copy, but still it's good practice to be passing const references if you're not planning on modifying the thing that's being passed in. Yeah. So you are correct in that you could provide an additional template parameter for the type of the thing that you're iterating over. And then you wouldn't have to pass, then that would allow you to break the circular reference, but you'd be making a lot of assumptions about the methods supported by your class, which are fine to do here because you know how it works, but generally that's not the way you'd want to go about doing it because that type is not changing. Right? The type, you're not ever replacing it with anything besides doubly linked list of T. But yes, it would allow you to break the circular reference that way. Hey, we got 2 minutes. Any other questions? Do you guys have any questions about like the linked list itself? That's the other point of confusion. Hopefully you're seeing that the code you have to write for your class is fairly simple, right? The iterators are fairly simple. It's not too complicated. Templating will give you some fun error messages that are hard to decipher. Remember, all your code needs to go into the header files, right? No CPPs. When you're creating your class, or when you're working on your project, it should kind of be looking like this, in that you have like your doubly linked list and your main and all that stuff here. And then another folder called doubly linked list that has your classes and stuff inside of it. You should only be making changes inside here. You shouldn't be changing anything out here as to what's going to be submitted, because I will always be using the same stuff that I provided you out here for testing your code. So any modifications you do here, they won't be used when we test it, right? They'll be completely erased and replaced by what I'm giving you for the default copy. Okay, maybe we'll finish Pokemon on Friday and talk about stuff next week. Hopefully that clears things up a lot for what you have to do. It's not that bad though.